This is my geometry course. Today we're going to focus on right triangles, specifically geometric mean theorems, special right triangles, and theorems relating to the Pythagorean theorem, which we learned previously. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Remember, if you don't do the homework in this course, it's a 100% guarantee that you're going to learn absolutely nothing in the entire course. So we're going to start with a review on the Pythagorean theorem. Remember, the Pythagorean theorem says that if you have a right triangle and the longest side, the hypotenuse, is C, and the other sides, called the legs, are A and B, then A squared plus B squared equals C squared. That's the Pythagorean theorem. Remember, the side opposite the 90-degree angle is always the longest side in a right triangle, and that is the hypotenuse, and the other sides are the legs. That's what they're called. So now we're going to do some practice problems. Again, this is stuff that you have already done, but we're just going to review the Pythagorean theorem because we're going to go into some other theorems, like I said, relating to the Pythagorean. So we have, it says here, find the unknown values. So we're going to use the Pythagorean theorem, a squared plus b squared equals c squared, because this is a right triangle. And remember, the side opposite the 90-degree angle, that's always going to be C. So we plug that in for C, and that doesn't matter what A is. It can be 5 or 12, and the other number is just going to be whatever the other number is. So now we just have to do the math. 5 squared is 25, 12 squared is 144. Remember, when you square a number, that's just raising it to the second power. That just means 5 times 5 is 25, and 12 times 12 is 144. Then you're going to add those numbers, we get 169. Now, we found x squared. We know x squared is 169, but we don't want x squared. We want x. So what you're going to do is you're going to get rid of that square by doing the opposite of squaring, which is square rooting. And remember, whenever you put a square root, you have to put a plus or minus sign. Now, if you're rusty on this, that's okay. If you've never seen this, that's not okay. You should have seen this in a beginning algebra course, which is a prerequisite for this course. So that gets rid of the second power on the x, and now we're left with x. And the square root of 169, you can do that on your calculator if you want, but it's going to be 13. 13 times 13 is 169. Remember, square root means what number times itself is equal to 169. So, and remember, whenever you square root both sides of an equation, you always put plus or minus. So x can be plus 13 or minus 13. But we're dealing with a geometric figure, and the length of a side can never be a negative number. So we're just going to get rid of that minus, and we're just going to put x is equal to positive 13. But I want you to write this plus or minus because that's one of the biggest mistakes, or the most common mistakes that students make when they square root both sides of an equation. They almost always, I would say 90% of the time, they always forget to put that plus or minus, and I want you to get in the habit of writing that. So now let's try another problem. We have a right triangle. Of course, we're going to use the Pythagorean theorem. And the side opposite 90 degrees is 17. That's C. That's always C. And we'll make A 8, and B will make P. So we're looking for P. And so 8 squared is 64, and 17 squared is 289. You can check that with your calculator. It's okay to use a calculator in this class. So now we have an equation with a square. Right, we're solving an equation with a square. We learned how to do this in my beginning algebra course. It's basically, it's pretty simple. You just isolate this square. It's not isolated right now because the 64 is next to it. So we're going to get rid of that 64 by subtracting 64 from both sides. And 289 minus 64 is 225. Again, you can use your calculator for that. That's okay. So now we isolated the square. We know that p squared equals 225. We don't want p squared. We want p. So you have to get rid of that second power on the p. So we're going to square root, which is the opposite of squaring. And remember, you got to put plus or minus not on both sides of the equation, but just the side with the opposite the variable. And then that gets rid of the second power, and we have plus or minus whatever square root of 225 is. So what number times itself is equal to 225? Well, that's going to be kind of hard to do without a calculator. You can do it by trial and error. You can try 10 times 10, that's 100. 11 times 11, that's 121, and just keep getting bigger and bigger. Eventually you're going to get to 15. But you can plug it in on your calculator. Write 225 in your calculator, and then push a button that looks something like this, and that'll turn this into 15. So again, you can use your calculator. That's completely fine. So now, of course, p cannot be a negative because it's the side of a triangle, so p is positive 15. And there we have our answer. All right, so let's do one more of these before you try some on your own. Again, we're just reviewing the Pythagorean Theorem. You might be thinking, well, why are we doing this? We already did this. Well, again, we're doing some things that relate to the Pythagorean Theorem, so we have to review. All right, so we have a right triangle. We're going to write the Pythagorean Theorem. And v squared and 1 squared is equal to root 17 squared. How do I know that c is root 17 and not these other numbers? Well, because root 17 is opposite 90 degrees. All right, so we have root 17. If you square a root, you're doing the opposite of square rooting it. So this power is the opposite of this square root. So what does that mean? Well, it just means that it gets rid of the square root. So you're now just left with 17. 1 squared, 1 times 1, is just 1. And of course, v squared we can't do anything with because we don't know exactly what v is yet. All right, so now we have an equation with the square. We can just isolate the squares, subtract 1 from both sides, and we get v squared is equal to 16. So we know that v squared is equal to 16. We don't want v squared. We want v. So we have to get rid of that square on v. And so we're going to do the opposite of squaring, which is square rooting. Square root both sides, and we end up with plus or minus 4, because 4 times 4 is 16. But of course, the side of a triangle can't be negative, so we're just going to write positive 4, and that is the answer. All right, now it's time for you to try. Go ahead and attempt number 4. Again, this should be review for you, and when you come back, we'll do it together. All right, we're back. So 3 squared plus 4 squared is equal to y squared. We have 9 plus 16 is equal to y squared. 9 plus 16 is 25. Square root both sides, and we get y is equal to plus or minus 5. But of course, a side of a triangle can only be positive. So if you got 5, good job. All right. Try number 5, and when you come back, we'll do it together. All right, we're back. 6 squared plus x squared is equal to 10 squared. And 6 squared is 36. 10 squared is 100. Subtract 36 from both sides, and we get 64. And square root both sides. And we have x is equal to plus or minus 8. But of course, the side of a triangle cannot be negative. So our answer is 8. So if you got 8, good job. Try number 6, and when you come back, we'll do it together. All right, we're back. We have 5 squared plus s squared is equal to square root 29 squared. Square root 29 squared is 29. 5 squared is 25. Subtract 25 from both sides, and we get 4. Square root both sides, and can't forget your plus or minus there. And we have s is equal to plus or minus 2, and s therefore is equal to 2. So if you got that answer, good job. So again, that's just all review of the Pythagorean theorem. Now we're going to go on to, like I said, some theorems relating to the Pythagorean theorem. We're going to start with the converse of the Pythagorean theorem. So we're switching things around. Before we said if a triangle is a right triangle, then a squared plus b squared equals c squared. Now we're switching the hypotenuse and the conclusion, and we're saying if c squared equals a squared plus b squared, then the triangle is a right triangle. So what this means is if the longest side of a triangle, or excuse me, if the square of the longest side of a triangle is equal to the sum of the squares of the other sides, then the triangle is a right triangle. So you can take a screenshot of that if you want. And there's one more theorem, or actually two theorems that we need to learn before we do some practice problems. It's also true that if the square of the longest side of a triangle is less than the sum of the squares of the other sides, then the triangle is acute. Now, you may not remember what acute means, an acute triangle. We went over that briefly in a previous class. That just means that all the inner angles in a triangle are less than 90 degrees. So, for example, here's an example of an acute triangle, because all these angles are less than 90. But here's an example of an obtuse triangle, because one of the angles is greater than 90. So that's what acute and obtuse mean when you are referring to triangles. So if the longest side in a triangle, if the square of the longest side in a triangle is less than the sum of the squares of the other sides, then the triangle is an acute triangle. But if the square of the longest side of a triangle is greater than the sum of the squares of the other sides, then the triangle is an obtuse triangle. So again, we learned three different theorems. We learned the converse of the Pythagorean theorem, and we learned these two Pythagorean inequality theorems. So if you didn't understand what all that means, that's okay. We're going to do some practice problems, and you're going to see exactly what this, or how this works. So it says here, are the following triangles acute, obtuse, or right triangles? So what we're going to do is we're going to analyze c squared and a squared and b squared, the sum of a squared and b squared, and we're going to find out, is the longest side greater than the sum of the squares of the other sides, less than, or equal to? And that's going to tell us if the triangle is acute, obtuse, or a right triangle. So let's see here, c squared, and I'm just going to write like a big bubble there, because we don't know if it's equal to or less than or greater than. So now the longest side, c always has to be the longest side. You must understand, c has to be the longest side, just like with a right triangle. So 11 is obviously the longest side, and it doesn't matter which one is which with the a and b. And so now you can get your calculator out. 11 times 11 is 121, and we have 64 plus 49. So 64 plus 49, you can get your calculator out for that. That would be 113. So you can see that 121 is greater than, remember Pac-Man wants to eat the bigger number. That's how a lot of students tell if you draw a Pac-Man with this thing, he wants to eat the bigger number. So that's how you know which way that inequality goes. So you can see that c squared, the longest side, the square of the longest side ended up being bigger than the sum of the squares of the other sides. So that means that the triangle is obtuse. And that's how you do these problems. It's pretty easy. So now let's try another one of those. And the longest side we can see is 10.6. So that goes on C. And a squared will just make 4. Or a will make 4 and b will make 10. And so we're definitely going to need a calculator for 10.6 squared. That's not easy to square. So 10.6 times 10.6 is 112.36. Again, don't be afraid to use a calculator for that. And we have 16 plus 100. So 112.36 and 116 if we add those two numbers. So in this case, we can see that c is less than, c squared is less than the sum of the squares of the other sides. So what does that prove? It proves that the triangle is an acute triangle, meaning all the angles in the triangle are less than 90 degrees. Whereas here we have one angle that is greater than 90 degrees. Okay, so let's try one more of these. Number 9, put a divider here. Again, we're using c squared and a squared plus b squared. The longest side is obviously root 8. We have root 3 squared plus root 5 squared. So root 8 squared is just 8 because we're just doing the opposite of square rooting. We're squaring. And then we have square root 3 squared is 3 and square root 5 squared is 5. So we have 8 and then 8. So you can see obviously that 8 is equal to 8. And therefore that proves that the triangle is a right triangle. And you can just put right. All right, now time for you to try. Go ahead and try number 10. Remember, the longest side has to be C. And you're going to need a calculator for number 10 unless you want to do a lot of arithmetic. So try number 10, and when you come back, we'll do it together. All right, we're back. C squared and a squared plus b squared. We're going to set up the structure. The longest side is obviously 29, so 29 squared. We want to know how that compares to 20 squared plus 21 squared. And if we get my calculator out, 29 times 29 is equal to 841. And 20 squared, that's pretty easy, that's 400. And 21 squared, that's equal to 441. If you add those together, you get 841. So you can see that these two numbers are equal. So the triangle is a right triangle. So if you got that answer, good job. Go ahead and try number 11. When you come back, we'll do it together. All right, we're back. We'll set up the structure here. The longest side is obviously 14, so 14 squared. And 12 squared plus 8 squared. 14 squared, you can use your calculator for that. 14 times 14 is 196. And we have 144 plus 64. 144 plus 64 is equal to 208. So you can see in this example, c squared is actually less than the sum of the squares of the other sides. So this means that the triangle is acute. So if you got acute, good job. All right, so for number 12, just be aware that you're going to have to square this little expression here. If you get stuck, that's okay, but you can go back to my beginning algebra course and look at simplifying radical expressions or expressions with square roots, or you can just watch me do it. But see if you can do number 12, and when you come back, we'll do it together. All right, we're back. We're going to set up our structure. And obviously the longest side, c, is going to be 3 root 5. And we're going to square that. And then we have 2 squared plus 6 squared. Now, this expression here, that means 3 root 5 times 3 root 5. So you just multiply the 3's and you get 9. And you multiply square root 5 and square root 5. And then you just get 5. Because square root 5 times square root 5 is just 5, because squaring is the opposite of square rooting. Now, if you're bewildered by that, that's okay. It may be a little familiar to you, but if it's completely unfamiliar to you, I don't know why I got rid of all that stuff. We're not done yet. So we have 9 times 5. The 3 times 3 is 9. Square root times square root 5 times square root 5 is 5. And then you just multiply these together and get 45. I know I'm rushing through that. But again, that's all review from my beginning algebra course. We don't really have time to go into that in detail. I'm not going to give you a lot of problems like that. I don't know if I'm even going to give you any problems like that in the homework, so don't be too concerned about that. So now we have 45 is obviously greater than 40, so that means the triangle is an obtuse triangle because c squared is 45 and the sum of the other squares is 40. So because the square of the longest side is bigger than the squares of the other sides, the sum of the squares of the other sides, it must be an obtuse triangle. So if you got that answer, good job. But if you got stuck, again, that's not a big deal. Don't be too nervous about that because of that root. It's common for students to forget that stuff from the beginning, my beginning algebra course or any beginning algebra course. All right, so now we're going to go on to geometric mean theorems. Now, geometric mean theorems are not really that important in the overall curriculum, the geometry curriculum. Some teachers don't even cover this at all. But because it is part of the geometry curriculum, we do have to go over it. So let's first talk about the concept of geometric mean. The geometric mean, and by the way, you may recognize mean from a previous course. Arithmetic mean, first of all, if you hear the word mean, if you hear mean, that's almost always referring to arithmetic mean. Arithmetic mean means if you have a list of numbers, the arithmetic mean is when you add all the numbers together and divide by how many numbers there are. So add these numbers together and then divide by 1, 2, 3, 4, 5. That's the arithmetic mean. We learned that in my arithmetic course. Okay, but the geometric mean is different. The geometric mean, and I should just keep those numbers, I guess. The geometric mean is when you multiply all those numbers. So you multiply them all together, and then you take the fifth root of all those numbers, because there's 5 numbers. And you're going to get something that is interpreted in a similar way to the arithmetic mean. Now, we don't have a lot of time to go into geometric mean and all that type of stuff. In fact, you've actually never learned the nth root. You've only learned the square root when n is equal to 2. But there's also cube roots, and there's fourth roots, and there's fifth roots. It's not a hard concept. For example, the cube root of 27 is 3. Why is that? Because if you multiply 3 times 3 times 3 3 times, you get 27. So it's not a hard concept. It's just, we're not going to go into it in detail here. But that is the geometric mean. For example, if you have 3, 4, and 12, and you want to find the geometric mean, you have to multiply all those numbers together. And then you have to take the cube root, the third root. Why the third root? Because there's 3 numbers. If you have 2 numbers, 10 and 7, and you want to find the geometric mean, you have to multiply those numbers together, and you have to take the square root. Now, this is a square root, but when we write square root, we never put the 2 there. You can put the 2 there if you want, but it's just traditional to leave it off. So we square root it, and we get 8.3667, and so on and so forth. So that is a geometric mean. And the only reason that we have to learn all that stuff, and by the way, you might want to take a screenshot of these theorems here. The only reason that we have to learn all that is because there's some expression in these next theorems that we need to use called the geometric mean. It's a fancy term, but it's really not even necessary. It's just something that you're going to hear. So the first theorem is the geometric mean theorem for altitudes. Now this only applies to right triangles. Remember, today we're studying right triangles. So you see we have a right triangle here, but I've done something really weird. I've put the right triangle so it's laying on its hypotenuse. Okay. And I know that that's hypotenuse because this is the right angle, but I've also drawn a right angle here. So what I've done is I've dropped down an altitude. Remember, we learned about altitudes of triangles. There are 3 altitudes of a triangle. We learned that in the class on points of concurrency generated by triangles. If you put the triangle on this side, then this would be the altitude. And if you put the triangle on this side, then this length would be the altitude. But we're putting the triangle on the hypotenuse, so that means that this length is the altitude. So we've taken a right triangle and we've set the triangle on its hypotenuse. We're making the hypotenuse the base, and we've drawn the altitude, setting it on its base. That's the altitude if you set it on its base, h. The geometric mean theorem for altitude says that the length of the height, the measure of the height, the length of this segment is the geometric mean of these 2 segments that are created by the intersection of the altitude with the hypotenuse. So again, I know that seems kind of confusing, but when we drop this altitude down, we cut this little, the hypotenuse, so we have one length here and another length here. So the height of the triangle, if it is a right triangle, the height from this angle to the hypotenuse is the geometric mean of those 2 lengths. So that's what this says. I know that seems kind of confusing. And by the way, this only applies to right triangles, the height of a right triangle, if you set it on its hypotenuse. This is very specific to this particular situation, which is why this really is not that important. It's not an important part of the geometry curriculum, but it is part of the geometry curriculum. Now, we also have geometric mean theorems for the legs of a right triangle, and that's these here. So you should definitely take a screenshot of these theorems if you haven't already. And again, if you're confused by this, that's okay. We're going to you're going to figure this out when we do practice problems. So these they say that if you want to find the leg of a right triangle, then that's equal to it's equal to the geometric mean of the hypotenuse C and one of those segments that were created, the segment next to A, the context A, and that's how you find A. But again, it's much easier just to explain with practice problems. So now that you have a screenshot of that, let's do some of these together. We have a right triangle and we set it on its hypotenuse. This is its hypotenuse. We set it on its hypotenuse. So x is obviously the altitude, so that theorem tells us, the geometric mean theorem for altitudes tells us that x is equal to the geometric mean of 4 and 9. So the square root of 4 and 9. So 4 times 9 is 36, and then what number times itself is equal to 36? Well, that's just 6. Very easy. So that was the geometric mean theorem for altitudes. Now we're going to use the geometric mean theorem for legs. So we want to find x. The geometric mean theorem for legs tells us that x is equal to the square root of the segment created by the altitude and the hypotenuse that is closest to x, and the overall hypotenuse, 7. Again, I know that seems kind of confusing, but you'll get used to it as you do these problems. So 7 times 2 is 14, and you can just leave it as square root 14 because we can't really simplify that much. All right, so let's see here now. We want to find, we're going to use a leg theorem, geometric mean theorem for legs also. X is equal to the geometric mean of 4, which is the side next to x, and the length of the hypotenuse. Now understand, we don't have the length of the hypotenuse in this problem. You have to add these 2 lengths to get the length of the hypotenuse. So 6 plus 4, that's the length of the hypotenuse. So this is we're getting kind of tricky here already. And we can just do 6 plus 4 is 10. And you don't need 2 parentheses, you just need 1 there. At this point, it's tempting to just say, well, multiply them together, we would get square root 40. But remember, you're not allowed to keep a perfect square inside a root. You see, 4 is a perfect square. So we're going to erase this, and we're just going to pull out that perfect square. Remember, root A, let me move this over a little bit. Root A times B is equal to root A times root B. I don't really have a lot of room to write that. I'll figure it out where to write it somewhere else. But we can write root 4 times root 10. That's just an algebraic principle we learned in my beginning algebra course. And root 4 is just 2. What number times itself is equal to 4? That's just 2. Then we can get rid of that dot, and we can just write 2 root 10. And that is the answer. So I know that's a lot, but if you're having trouble with that, again, you can go back to my beginning algebra course under roots, or simplifying expressions with roots, or simplifying expressions with radicals. I don't remember what I called it. All right, so continuing on here, we're going to do one more of these before you try some of these on your own. And I'll go back to those geometric mean theorems if you forgot to take a screenshot, because as you're going through this, you're probably thinking, man, this is a little hard to remember. Now in this problem, the altitude, we actually know what it is. So we can just write 9, the altitude is equal to the geometric mean of 6 and x, so 6 times x. So this is different because usually we're looking for the altitude, but in this problem we have the altitude and we're looking for one of those segments created by the intersection of the altitude with the hypotenuse. So now we have an equation with a square root. This is also something we learned in my beginning algebra course. If you have an equation with a square root, you get rid of the square root, or first you isolate the square root. The square root is isolated because there's nothing around it. There's no plus 7 or anything like that. So we isolate the square root, then you get rid of that square root. And the way you get rid of a square root is by doing the opposite of square rooting, which is squaring. So then 9 times 9 is 81, and we get rid of that square root, and we're left with what's inside the square root. And then we just have to divide both sides by 6, and we get 81 over 6. And then we can reduce that. So divide both sides by 3, and we get 27 over 2 is equal to x. And you can change that to 13.5 if you want to, but I'm just going to leave it as 27 over 2. So again, a lot of different problems here. Why don't you try number 17? And I'm going to give you a chance to take a screenshot of those theorems if you haven't already taken a screenshot. So go ahead and try number 17. You're going to use the geometric mean theorem for altitudes on this problem. So try 17, and when you come back, we'll do it together. All right, we're back. The geometric mean theorem for altitudes tells us that the altitude is the geometric mean between those two segments. And you can use a dot or whatever you want to use for the square root. So 5 times 8 is 40. So now we're going to factor that just like we factored it in the other problem, or it actually was factored for us in the other problem. Well, I know 4 times 10 is 40. So then we can break it into parts. And y is equal to 2 times root 10, and you can just get rid of the dot, and we have 2 root 10. A lot of students are very angered by the fact that you can write a number right next to a root, and that means multiplication, but that's just the way it is in math. That's the notation. If you put a number right next to a root, it means that you're multiplying the number by the root. All right, so on the next problem, you're going to use a geometric mean theorem for legs. So try number 18. Remember, 8 is c, and 6 is going to be x or y, and this number is going to be a or b in those equations. So try number 18, and when you come back, we'll do it together. All right, we're back. The geometric mean theorem for legs tells us that x is equal to the geometric mean of 6 and 8. Whoops, why did I write 2 x's? Sorry about that. So 6 times 8 is 48. But remember, you can't leave a perfect square inside a root. Now I know that 48, you might have to do some division with your calculator, but I know that 48 is 16 times 3. And I can pull out that 16. Square root of 16 is 4. And I don't really have a lot of room here, so I'm not going to show every step. But you just pull out that 16 as a 4, and you should have 4 root 3. So if you got that answer, good job. Okay, go ahead and try number 19. But for 19, be aware that you're not given the hypotenuse. You actually have to find the hypotenuse. But that's pretty easy because you just add these two numbers together to find the hypotenuse. So try number 19, and when you come back, we'll do it together. All right, we're back. X is equal to the geometric mean of the hypotenuse and the number next to x, which is 5. The hypotenuse is just 4 plus 5. So now x is equal to 5 times whatever 4 plus 5 is, and that just happens to be 9. And we can go ahead and multiply these to get 45. But why would we do that when we already know that 9 is a perfect square? So 9 comes out, we're going to square root 9. What number times itself is equal to 9? That's 3. So 9 comes out as a 3, and the 5 stays in. Again, if you're rusty on this, I expect students to be rusty on this, to not remember this stuff. So that's okay. You can just go back to my beginning algebra course and review that material. But if you've never seen this stuff at all, then that's going to be a problem. Now, I could do a lot of review with this stuff in this course, but I really don't want to do that. Again, these theorems are not really that important, so I don't want to spend a lot of time doing roots just to review these theorems. So again, if you're very nervous about this and you don't understand what I'm doing with these roots, that's okay. Just go back to my beginning algebra course. Technically, you should know how to use those roots. But between me and you, students always, at this stage in their math education, they always forget, so they need review on that. But again, I'm not going to review that material because it would be too extensive to have to go over that, and it's going to make this curriculum too big. All right, so for number 20, you're going to use the geometric mean theorem for altitudes. But remember, in this problem, we have the altitude, so you're going to have to solve an equation with the root. So go ahead and try number 20. Do your best, and if you get stuck, that's okay. But be sure to attempt that problem. See if you can do it on your own. And when you come back, we'll do it together. All right, we're back. So the altitude is equal to the geometric mean of 16 and x. So now we have an equation with a square root. We have to isolate the square root, and it's already isolated. Then we have to square both sides to get rid of that root, because we don't want to have to deal with that root in the equation. We want to make the equation simpler, so we're going to get rid of the root. So 12 squared is 144, and on the right side of the equation, that just gets rid of the root. And now we're just going to divide both sides by 16. So 144 divided by 16 is equal to 9. So x is equal to 9. All right, so if you got 9, good job. If students have trouble, it's most likely going to be with these roots, because this is stuff that you may not have learned, or it's been a while since you went over this stuff. Now 21, that's going to be pretty much the same type of problem, so see if you can do 21, and when you come back, we'll do it together. All right, we're back. The altitude is equal to the geometric mean of 12 and y. Square both sides, 18 squared. I'm going to use my calculator for that. That's 324, so the numbers on these are getting kind of large. Then I'm going to divide both sides by 12, and we get y is equal to 27. So we got 27, good job. Now, you should have been using your calculator on that problem because there's a lot of big numbers. All right, so now we're going to learn about special right triangles. There's a lot of triangles that are special, but these are special right triangles. So if you look at the class of right triangles, these are particularly important. And the reason they're important is these particular triangles are used quite frequently in upper mathematics. So if we learn the properties of them, it'll help us to do problems more quickly. And there's only two special right triangles we're going to learn today. That's the 30-60-90 triangle and the 45-45-90 triangle. So I'm going to give you a chance to take screenshots of those. You can go ahead and take a screenshot of this one if you want. Now, why is this triangle called a 30-60-90 triangle? It's called a 30-60-90 because one inner angle is 30 and another angle is 60 and the last angle is 90. That's why it's called 30-60-90. Now, what does this 30-60-90 triangle theorem tell us? It tells us that the length of the side opposite the 30-degree angle, the length of the side, whatever that length is, whatever that number is, we'll call it W, the length of the hypotenuse is double that length. That's always true for a 30-60-90 degree triangle. And the side opposite the 60-degree angle is that number W times root 3. So that's just the way it is with every 30-60-90 triangle. So I know what you're thinking. You're thinking, what in the world does that mean? Well, you're going to see that it seems kind of confusing, but when we do practice problems, you're going to see how this works. So I'm going to try to leave this in the window so you can see what's going on. In this problem here, well, we're supposed to find the unknowns as usual. In this problem, the length of the side opposite 30 degrees is 2, right? So what that means is that the hypotenuse is double that number. So the hypotenuse is 2 times 2, which is 4. That's one of the answers. Because remember, whatever this side is, the side opposite 30, the hypotenuse has to be double that. And this side here, that has to be 2 times root 3. Because, again, whatever this number is, whatever W is, the side opposite 60 has to be root 3 times W. Again, that's just the way these triangles work. So X has to be what W is, 2 times root 3. And that is the answer for X. So these problems are really easy as long as you understand what this picture is telling us. So I'm going to do one more of those before you try this on your own, because you can see it's pretty easy. This is just something you have to remember. So the side opposite 30 degrees is 13, right? That's the length of that side. So this theorem here tells us that the hypotenuse must be double that. So y is equal to 2 times 13, which is equal to 26. So again, very simple. And the side that is opposite the 60-degree angle, x, that side has to be whatever w is, in this case 13, and it has to be times root 3. So again, this is very easy. All right, so hopefully you've got the idea. Go ahead and try number 24. Now again, understand how this works. You're going to first ask yourself, what is the side opposite the 30-degree angle? Once you find the side opposite the 30-degree angle, you can easily find the other two sides using this picture up here. So I'm going to leave that picture in the window and go ahead and try number 24. When you come back, we'll do it together. All right, we're back. The length of the side opposite 30 is 14. So the hypotenuse, the side opposite 90 degrees, that must be double that side. So it must be 28. So y is equal to 28. And x is whatever that length is, whatever this length is, times root 3. And there you go. Very easy. So I know this seems very unfamiliar to you, and you're probably thinking, I don't understand like why we have to learn this. But for now, just understand that this is something you're going to be using in upper math and it's going to be extremely common. Why don't you, again, take a screenshot of this, and let's see here. Maybe I'll just copy that and bring it up for you, so you don't have to take a screenshot necessarily. So I'm going to put that up there so you can refer to it. Go ahead and try number 25. Again, you want to use this picture. You want to have this picture in your head as you're doing these problems. And when you come back, we'll do it together. All right, we're back. So the side opposite 30 degrees, the length of the side opposite 30 degrees is 6. So that means the hypotenuse is 2 times 6. That's the way it always is with these particular special triangles. Again, these are special triangles. This doesn't always work for every right triangle. And the side opposite 60 degrees, that side has to be whatever the side opposite 30 is times root 3. So if you got those answers, good job. All right, so now we're going to go to something a little bit more difficult, but it's not really that hard. In this problem, we're not given the side opposite 30 degrees. And all the previous problems with this special triangle, this 30, 60, 90 triangle, we were given the side opposite 30. We don't have the side opposite 30. That side is x. We don't know what it is. In this problem, they're giving us the side of the they're giving us the length of the hypotenuse. But we know that the length of the hypotenuse is double the length of the side opposite 30 because of this picture right here. So that means that x is just going to be half of 14. So x is equal to 14 divided by 2, which is equal to 7. So x is equal to 7. Let me put a divider here, move that over. And now that we know that the side opposite 30 is 7, this side opposite 30, we know that it's 7 now. We know that y, the side opposite 60, is going to be whatever that side is opposite 30 times root 3. So 7 root 3. Again, if you understand what this means, if you understand what this structure means, this triangle, these problems are pretty easy. All right, so let's do one more of those problems before you try one on your own. So again, in this problem, we're given the hypotenuse, just like we were given the hypotenuse in number 26. We're not given the side opposite 30 degrees. We're given the hypotenuse. So again, using this picture up here, we know that the side opposite 30, which is y, is going to be half of the hypotenuse, which is 4. So y is 4. And the side opposite 60 is going to be whatever that number is opposite 30 times root 3. So x is equal to 4 root 3. So very, very easy. Now I want you to understand something. Notice that there's no angle here. There's no 60-degree angle there. So wait a second, how do we know that this triangle is a 30, 60, 90 triangle? Well, remember the triangle sum theorem. All these angles have to add up to 180. If this angle is 30 and this angle is 90, then just doing basic arithmetic, we can see that this angle must be 60. So we don't need all of the angles to know that it's a 30, 60, 90 triangle. And we know that this is 60, so x is opposite 60. So in some of these problems, you're not going to be given all of the angles, but you still can figure out if it's a special triangle. So why don't you try number 28. I'm going to bring this picture down so you can use that. Try number 28, and when you come back, we'll do it together. Remember, you're given the hypotenuse. The length of the side opposite 30 is half the hypotenuse, and the length of the side opposite 60 is the length opposite 30 times root 3. And remember, you're not given all the angles, but we know this is 30 degrees. It has to be 30. So this is the side opposite 30. So try number 28, and when you come back, we'll do it together. All right, we're back. So the hypotenuse is 22, so the side opposite 30, which is y, again, we don't see that 30 degrees, but we know it's 30 degrees. Y is going to be 22 divided by 2, which is just 11. So if you got 11, good job. And x is going to be equal to whatever that side is opposite 30, which we found is 11, times root 3. So 11 root 3. So if you got those answers, good job. Again, we're using this picture right here, and I can probably bring that down a little bit. So now try number 29. Again, we're given the hypotenuse, the same type of problem, and when you come back, we'll do it together. All right, we're back. So the side opposite 30 degrees is half of 18. So x is equal to 18 divided by 2, which is 9. And now that we know the side opposite 30, we know that the side opposite 60 is the side opposite 30 times root 3. That's just what this picture tells us. So if you got 9 root 3, good job. All right. Now we're going to go to some slightly different type of problem. Again, we're just practicing 30, 60, 90 degree triangles and this information, how to use that information to simplify these problems. Now we're given the side opposite 60 degrees. So in the first problems, we were given the side opposite 30 degrees. In the second problems, we were given the side, the hypotenuse. And in this problem, we're given the side opposite 60 degrees. But notice that the side opposite 60 degrees is a multiple of root 3. That means 10 times root 3. So because we know that the side opposite 60 is some multiple of root 3, and whatever that number is, we multiply by root 3, that number has to be the side opposite 30. We can see that the side opposite 30, which in this case is x, must be 10, because the 10 is right next to the root 3. Again, there's a billion different ways I could explain this, but if you just understand what this means, I don't need to go into a huge explanation. Again, these problems are pretty easy. So this is 10 root 3 right here. The side opposite 30 degrees is whatever that number is multiplied by root 3. So in this case, we had 10 root 3, so the side opposite 30 is 10. Now, the hypotenuse is going to be whatever the side opposite 30 degrees is times 2. So it's going to be 10 times 2, because the side opposite 30 degrees is 10. So again, just like in the previous problems, we just take that side opposite 30 degrees and multiply it by 2 to get the hypotenuse. All right, so let's do one more of these problems before you try one on your own. Again, we have the side opposite 60 degrees. Again, we know this side with this angle is 60 because we're just using the angle sum theorem. So this is w root 3. I'm going to bring that shape over. Again, consult with this shape here, this figure, to understand what's going on here. This side is 5 root 3. So if the side opposite 60 is 5 root 3, then that means the side opposite 30 must be whatever you're multiplying by 3. In this case, it is 5. So x is equal to 5. Very easy. Now, y is the hypotenuse, so y is whatever the side opposite 30 is times 2. So that would be 5 times 2, which is equal to 10. So again, very, very easy. So now it's time for you to try. I'm going to bring this shape over. Remember, we're given the side opposite 60 in these problems. So you need to figure out what is multiplied into root 3, opposite 60, and you're going to use that to find the other sides. So try number 32, and when you come back, we'll do it together. All right, we're back. So the side opposite 60 is 11 root 3, so that means the side opposite 30, which is x, has to be 11. And the hypotenuse is 2 times the side opposite 30, so 11 times 2, which is 22. So if you got those answers, good job. Go ahead and try number 33, and when you come back, we'll do it together. All right, we're back. So the side opposite 60 degrees is 46 root 3. So that means the side opposite 30 degrees is going to be whatever is multiplied into root 3, 46. And the hypotenuse is just going to be 2 times whatever is opposite the 36 degree angle, which is 46. So 2 times 46, that would be 92. So if you got 92, good job. You can use a calculator for that if you don't want to multiply 2 times 46. All right, so now we're going to go to some slightly more difficult problems. I don't want to give you these problems, but I have to because I mean they're not that difficult. It's just that you have to use roots, and we're not doing a lot of review on roots, so you might have to go back to my beginning algebra course and do a little review on that if what I show you is not enough. But we have a root here. The side opposite 30 degrees is 4 root 3. So this is different. Don't be confused by this. This is not the side opposite 60, you see. If this were the side opposite 60, this problem would be easy. It would be just like the problems we did before. It's not the side opposite 60. It's the side opposite 30. So that means that this value here is W. Now, in order to find the hypotenuse, we multiply that number by 2. So the hypotenuse is 2 times W, 2 times the side opposite 30. And if you forgot how to multiply that expression, again, that's just something we learned in my beginning algebra course, which is a prerequisite for this course. You just multiply and you get 8 root 3, very easy. Again, you can go back and review that simplifying expressions with roots or radicals in my beginning algebra course if you need to do that. So now y is going to be whatever the side is opposite 30 times root 3. W times root 3. So we have 4 root 3 times root 3. So this is going to give some students some anxiety if you haven't done this in a long time. When you multiply a root by itself, that's and the number inside the root is the same, it just gets rid of the root. So now we're left with 4 times 3. Or maybe I should reorder that just so you can see what's going on. So we have 4 root 3 squared. That's what root 3 times root 3 means. And that would just equal 4 times 3, because when you square a root, it just gets rid of the root. And we're left with 12. So that one was a little tricky. So again, in this problem, we have the same situation. We have a root that's opposite 30 degrees. So you're going to need to use your knowledge of roots. So if you get stuck in this problem, that's okay. You can just wait for me to show you how to do the problem if you get stuck. And you might be thinking, well, how come you don't just do a lot of review of roots? Why don't we just go back over roots? Well, if we did that, you know, this class would be twice as long, and we just don't have time. And if we go into roots, then we're just going to have to teach an entire class on roots. And I don't want to do that just for these few problems that have roots. So if for some reason you don't remember how to do roots, how to deal with roots, again, you can just go to my beginning algebra course and review that material. Some students may need to do that, other students may not. So I'll just leave that to your discretion. So try number 35, and when you come back, we'll do it together. All right, we're back. So the side opposite 30 degrees is root 6. So the hypotenuse is double the side opposite 30, so 2 root 6. And remember, whenever you put a number next to a root, that just means you're multiplying the number by the root. Don't be confused by that. Now x is opposite 60 degrees, so whatever the angle, whatever the side is opposite 30, that's going to be multiplied by root 3, and that'll give us the side opposite 60. Again, that's what this shape tells us, that whatever the side is opposite 30, the side opposite 60 is going to be that number multiplied by root 3. Why is that? Well, again, that's just the way that these 30, 60, 90 triangles work. So now you have to multiply root 6 times root 3. This is something that I don't think we did today. So I kind of threw a trick here at you. So root 6 times root 3 is root 18. You just multiply them together. It's that simple. In this example, we multiplied roots together, but they just happen to be the same number. So, you could write root 9, but then that just simplifies to root 3 in the previous problem. There are many different ways to do this. So now we're going to factor root 18 because we have a perfect square inside there. And we're going to separate it, root 9 times root 2. Again, this is all review of my beginning algebra course. And root 9, what number times itself is equal to 9? That's just 3. Get rid of the dot, and you have 3 root 2. So x is equal to 3 root 2. So if you had trouble with that, that's okay. Again, you can go back to my beginning algebra course if you need to review that stuff. All right, so number 36, we'll do that one together. This is going to be a little different. Now we have the hypotenuse. The hypotenuse is a root. In the previous problems, the hypotenuse was just a regular number, and this wasn't really that difficult. But now it's a root, so we're going to have to do some strange things here. So remember, the side opposite 30 is just half of the hypotenuse. So y is just the hypotenuse divided by 2. And that's it. Pretty simple. So you don't need to simplify it even anymore. And by the way, you cannot divide 10 by 2 because the 2 is not inside the root. The 10 is inside the root, so don't divide 10 by 2. All right, and now x is the side that is opposite the 30-degree angle, which we just found. But remember, it has to be multiplied by root 3. So this is w, and we're multiplying w by root 3 to find the side opposite 60 degrees. So now we're just multiplying a fraction by a whole number. Remember, when you do that, you can just write, well, let me show you. You can just write root 3, which is considered to be the whole number, as over 1. Then you multiply the numerator straight across and the denominator straight across. So 2 times 1 is 2. And 3 root 10 times root 3, you just multiply 10 and 3 to get root 30. And there's no perfect square inside root 30. So you can just leave it as root 30. Now I know a lot of students are going to say, well, I want to divide 30 by 2. Well, no, you can't do that because the 30 is inside the root. All right, so it's time for you to try a problem like that. I'm going to give you a slightly easier problem. We're given the hypotenuse. Now remember, to find the side opposite 30 degrees, you just take the hypotenuse and divide by 2. So try number 37, and when you come back, we'll do it together. All right, we're back. So the side opposite 30 degrees is x, and x is the hypotenuse divided by 2. Now, in this case, you can divide 6 by 2 because 6 is not inside the root. So I'm sorry I tricked you on that one. Again, there's a lot of things here that we're going over that you may not remember from beginning algebra. That's okay. But you're going to need to go back to beginning algebra. I don't want to teach an entire root class on roots here. So it really just depends. Your need to go back to that beginning algebra course or that class is dependent on your strength when it comes to roots. All right, now the side opposite 60, that's just equal to the side opposite 30, which we just found, times root 3. So now we're multiplying roots again, so root 2 times root 3, that's just going to be root 6. And you can't combine the 3 and the root 6. So if you got that answer, good job. If you didn't get that answer, if you got stuck because of those roots, that's okay. Just, go back to my beginning algebra course and figure out how to do those roots. All right, so we have one more type of problem here. We could give a lot of different problems with these special triangles, but I don't want to bore you by just going over tons and tons of various problems. The most important thing is you get the general idea of how to use this figure. So, and And again, the special triangles are not the most important part of this course. They're really not a huge part of this course. So, you know, that's why I'm not forcing you to relearn the roots. But you're going to be required to do this when you take a test. All right, so this is a different problem because we have the side opposite 60 degrees, and it's not a multiple of root 3. So this is going to be more challenging simply because we're going to need to use roots, and the concept actually is a little more challenging. What we want to do is we want to find, obviously, the side opposite 30 degrees. This special triangle tells us that the side opposite 60 degrees, which is 7, that side has to be the side opposite 30 degrees, in this case is x, times root 3. So again, this is a harder problem because we're going to have to solve an equation now. So again, this side is opposite 60 degrees, right? We know that this is a 60-degree angle. So 7 is the side opposite 60 degrees. That side must be equal to the side opposite 30 degrees times root 3. So this is, if we can solve for this variable here, that is the side opposite 30 degrees. That's x. So this is usually where students start to have some problems with this type of stuff. And solving this equation is going to take some knowledge of expressions with square roots. So what we're going to do is we're going to isolate x. We're going to get rid of this root 3 by dividing both sides by x, or excuse me, dividing both sides by root 3. And we end up with x is equal to 7 root 3. And so at this point, we can't leave this expression. Remember, if you took my beginning algebra course, you know that we can't leave a square root in the denominator. Mathematicians don't allow that. You could. I mean, this is the correct answer, but we don't leave it in that form. So what you're going to do is you're going to use the fundamental principle of fractions, and you're going to multiply both sides of that fraction by root 3. Remember, you can't just multiply one side because that changes the value of the fraction. Now, the big question, obviously, is why are we multiplying both sides by root 3? Well, if you multiply these, there's a number of ways to think about it. Let's do the easy part first. So 7 times root 3, we can just write that as 7 root 3. That's no problem. There's not much else we can do with that. But the bottom, there's a couple ways to do this. You could write it as root 3 squared, and then you can see that the square and the root just cancel out. You're left with 3. Or you can just multiply them and write root 9. But we know that root 9 is just going to be 3. So we end up with 7 root 3 over 3, and that is the answer. So as you can see, because we had to rationalize the denominator, that problem was a little more involved. And now we're going to find y. Remember, y is just going to be double x, because y is the hypotenuse. So it's going to be double whatever the side opposite the 30-degree angle. So y is equal to 2 times 7 root 3 over 3, the number we just found. And remember, when you're multiplying a whole number by a fraction, you can just write the whole number as over 1. And now we're just multiplying fractions. You can use a dot or you can use parentheses, whatever you want. Parentheses are probably better. So I'll just use parentheses. So we're going to multiply the numerator straight across. 2 times 7 root 3 is 14 root 3. And 3 times 1 is 3. And that is the answer for y. 14 root 3 over 3. All right, so why don't you try number 39. I'm going to leave 38 in the window, and you have your figure here to refer back to. Remember, this problem is going to be a little bit more difficult because you're going to have to rationalize the denominator when you get a fraction of this form. So try number 39, and when you come back, we'll do it together. All right, we're back. we have the side opposite the 60-degree angle, which is 11. And we know the side opposite the 60-degree angle must be equal to the length of the side opposite the 30-degree angle, which we know as y. We don't know what y is, but we know that is called y, times root 3. So again, the side opposite the 60-degree angle must be equal to the side opposite the 30-degree angle times root 3. That's what this figure tells us. That's the 30, 60, 90 triangle theorem. So now we're going to divide both sides by root 3, and we get that expression there. And we're now going to multiply both sides of that fraction by root 3 to rationalize the denominator. Remember, we can't have roots in the denominator. And so we get 11 root 3 over root 9. And root 9, the square root of 9, that's just what number times itself is equal to 9. That would just be 3. So we now know that y is equal to 11 root 3 over 3. Now, to find the hypotenuse, and again, what we just found is the length of the side opposite the 30-degree angle. So we have w in this figure, the equivalent of w. So now to find the hypotenuse, we just multiply that number by 2. That's what that figure tells us to do. So x is just going to be the number we just found times 2. And again, you can treat that 2 as a fraction. That's the easiest way for people to do it. And then we get 2 times 11 root 3 is 22 root 3. And 3 times 1 is 3. So if you got those answers, good job. Let me rectangle y. If you got stuck, that's okay. But you do need to figure out what you did wrong, because you're going to need to do these types of problems in the homework. There's not going to be a lot of these problems, but there are going to be some in the homework. All right, so that was 30, 60, 90-degree triangles. Now we're going to go to the last type of triangle, and this is going to go a lot faster because you see how this works now. Now we just have a different type of right triangle, but it's the same principle. You have this expression, and this 45, 45, 90 triangle, and again, the reason it's called 45, 45, 90 is because the inner angles. Because two of the angles are the same, remember the theorems that we learned about isosceles triangles. This is an isosceles triangle. If two of the angles are equal, that means two of the sides must be equal also. So if these two sides are both w, the 45, 45, 90 triangle theorem tells us that the hypotenuse must be that number, whatever it is, w, times root 2. So this theorem is actually a lot easier than the 30, 60, 90 theorem. So let's do a couple practice problems. And I'm going to try to leave that shape in the window there. Number 40, we have w. W is 10. It's the side opposite 45. So that theorem tells us that the hypotenuse, which is what we're looking for, must be equal to w, which is 10, times root 2. And we're done. Very simple. Most of these problems are really easy. It's only the problems where you have to rationalize the denominator or do some weird thing with a root that are difficult. So now in 41, we're going backwards. In 41, we know that the hypotenuse, we see the hypotenuse is a multiple of, it's the product of root 2 and some number. So we can see that w is 3. So this is an easy one. So because the hypotenuse is 3 times root 2, x, the other sides, must be whatever is multiplied by root 2, which is 3, and we're done. Very easy. So hopefully you see how this is working. So 42 is going to be a little bit more difficult because now we have 5 root 2 is equal to w. So this is a little confusing. Root 2 has nothing to do. These root 2's here, they have nothing to do with that root 2. So don't be tricked by that. So we have w. W is equal to 5 root 2. So this theorem tells us that the hypotenuse is equal to the length of the legs, w, times root 2. That's the hypotenuse. So if we multiply those, again, there's a lot of different ways to do that. Root 2 times root 2 is root 4. That's one way to do it. And then root 4, what number times itself is equal to 4? That's just 2. And then 5 times 2 is 10. Again, there's a lot of different ways that you can do problems with roots. You don't really even have to show all these steps if you know how to multiply roots. You can just write the answer. All right, so we're going to try one more of these problems together before you try some on your own. So this is a problem that is going to be a little bit more difficult. Let me copy this and bring it over. Again, you should be using these shapes, these figures as your guide. You want to have these figures right in front of you the whole time. The 30, 60, 90 figure and the 45, 45, 90 figure. So in this problem, we're given the hypotenuse, and we want to find the legs. We want to find w. W in relation to this picture, x in relation to the picture we're using, obviously. So 8 is equal to this number times root 2. So we're kind of going backwards on this problem. That's what this picture tells us. So now we're going to divide both sides by root 2. And now we have a problem because we have a root in the denominator. We're not allowed to have a root in the denominator. So we're going to multiply both sides by root 2. Now, why are we going to multiply by root 2? Well, because it's going to get rid of the root. That's a special number we're going to use to get rid of that root. Again, I'm not really explaining much about this because we went over it in my beginning algebra course. So 8 times root 2, we can't really do much with that. We just write 8 root 2. And then root 2 times root 2 is root 4. But that just simplifies to 2. What number times itself is equal to 4? That's just 2. So now we have some more steps here because 8 is outside of the root, so we can actually divide 8 by 2. 8 divided by 2 is 4, so we have 4 root 2. So the answer to that one is 4 root 2. Now, before we go on, I want you to notice something. In this triangle, we had two 45-degree angles, right, and a 90-degree angle. So we knew it was a 45, 45, 90. In this triangle, we didn't have both angles. We didn't have both 45-degree angles. But again, with the triangle sum theory, we know that this must be 45, and therefore we know it must be a 45, 45, 90 triangle. Now in this triangle, we didn't have either of these angles. We knew that this angle is 90, but we didn't have either of these two angles. So how do we know it's a 45, 45, 90? Well, we know it's a 45, 45, 90 because these sides are the same. Remember the theorems that we learned about isosceles triangles. Because these sides are the same, that means that these angles must be the same. Now think about it. If these angles must be the same, and this angle is 90 degrees, if we use the triangle sum theorem, that will prove that these two angles must be 45 degrees. So don't let that trick you. Sometimes we can identify a 45, 45, 90 degree triangle without actually knowing the angles. The only thing we know is that these angles are the same because they both have an arc. Now here we have another theorem relating to the isosceles triangle theorems. We don't know these angles, and we don't know that they're equal. But we do know that this side is equal to this side, and that proves with the isosceles triangle theorems, that proves that this angle is equal to this angle. And so because they're equal, you can use the triangle sum theorem to prove that both these angles must be 45 degrees, so we're dealing with a 45, 45, 90 triangle. So just be aware of all that. You're going to have to identify when a triangle is a 45, 45, 90 degree triangle. All right, it's time for you to try a problem now. Again, you have to use this shape. Be sure to use that shape up there. I'm going to throw that up there. Actually, I'll just put it right here. We're going to start with an easy one, so try 44, and when you come back, we'll do it together. All right, we're back. So we know that the sides opposite 45 degrees are 5. They're both 5. So this figure here tells us that the hypotenuse must be that number times root 2. So if you got 5 root 2, good job. That was an easy one. Now for 45, we're kind of going backwards. So try number 45, and when you come back, we'll do it together. All right, we're back. So the hypotenuse is 9 times root 2, which means that the sides opposite 45 degrees, they must be whatever is multiplied by root 2 in the hypotenuse. So that is 9. So x is equal to 9. So again, that was an easy problem. So if you got that answer, good job. Let's bring this down. We have just a couple more problems. Why don't you try number 46? 46 is going to be a little bit more involved. If you get stuck, that's okay. But go ahead and attempt number 46, and when you come back, we'll do it together. All right, we're back. So we know that a side opposite 45 degrees is root 5. And we know that this side is opposite the same angle because this angle and this angle are equal. So this side must be root 5 also. So x is equal to root 5. We didn't do a problem like that before, so that was kind of an extra little trick there. And this side is equal to whatever the side opposite 45 degrees is times root 2. Again, based on this picture. So y is equal to root 5 times root 2, which is just root 10. And there you go. So if you got those answers, good job. All right, now number 47 is going to be the harder problem because you're going to end up with a fraction with a root in the denominator. So just be aware of that. Try your best on number 47. When you come back, we'll do it together. All right, we're back. So the hypotenuse is 6. But based on this information, we know that the hypotenuse must be equal to the length of the side opposite 45 degrees times root 2. So the length of the side opposite 45 degrees is x, and so that must be times that number times root 2 must be equal to the hypotenuse. So now if we divide both sides by root 2, we can solve for x, and we want to now rationalize the denominator, so we're going to multiply both sides by root 2, and we get 6 root 2 over root 4. And root 4 is just 2. And 6 divided by 2 is 3, so we have 3 root 2. So if you got that answer, good job. So that was the class today. If you'd like to take screenshots of all the work that we did to help you with the homework and to study for tests, go ahead and do that now. Screenshot number 1. Screenshot number 2. Screenshot number 3. Screenshot number 4. Screenshot number 5. Screenshot number 6. Screenshot number 7. And screenshot number 8. Now don't leave before you get the homework. So this is screenshot number 1 of the homework. And screenshot number 2 of the homework. And screenshot number 3 of the homework. So be sure to do that homework completely and correctly and neatly, and be sure it's in the correct chronological order. And remember, if you don't do that homework, it's a 100% guarantee that you're going to learn nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.